Welcome to JSR Maths Academy. In this video, I would like to cover some of the important concepts of rational numbers, which is useful to the class 9 and class 8. So, after completion of this video, 8th class students are able to do the problems of class 8 first chapter, that is of rational numbers, and the 9th class students are able to do the first exercise of real numbers. So, without wasting our time, let us get into the topic, that is of rational numbers. Okay, rational numbers. What is the definition of rational numbers? The numbers of form P by Q, where P and Q are integers and Q is not at 0, are known as rational numbers. Then the collection of rational numbers is denoted by Q, and it is written as Q is equal to set of P by Q, where P and Q are integers and Q is not equal to 0. See, first of all, let us understand the definition of rational numbers. Rational numbers means what? The numbers which can be written in the form of P by Q. The numbers which can be written in the form of P by Q are said to be as rational numbers. And here, this P and Q are belongs to integers and Q should not be equal to 0. You may get one more doubt. Sir, it is in the P by Q form. Rational numbers means what? P by Q form, that is of fractions. Then, what is the difference between the fraction and rational numbers? Means, fractions means what? The numbers which are in the form of P by Q, where P and Q are belongs to natural numbers or whole numbers where Q is not equal to 0. That means in the fraction, we will not cover the negative numbers. That means we will not cover the negative integers in that. But where we can use the negative integers means in the rational numbers. That's why that is the difference between the rational numbers and fractions. Okay. Now, rational numbers. The word rational comes from the word ratio and Q comes from the word quotient. Here you may have one more doubt. Natural numbers start with the N, so we represent it with the N, and whole numbers start with the W, so set of whole numbers is represented by W, and set of integers started with the I, and we represented it by I or Z. Z means we already learned that Jalen, which is meaning of that to count. And here also rational numbers, set of rational numbers start with the R. Then why can't we represent it with the R? Then why are we using Q to represent the rational numbers? Means this Q comes from the word quotient. That means if you take a fraction, let us take a fraction 1 by 2 is that. Then if you want to convert into decimal form, then what we need to do? We need to divide the numerator by denominator to, as a divisor, dividend is smaller than the divisor, we have to take 0 and take decimal point so that we can take 0. Then dividend becomes 10. When how many times we can subtract 2 from the 10 means 5. So you get 0.5. The value of this we got as a 0.5. In which part you got? Means in quotient place we got. In the quotient place we got this value of this rational number 0.5. So that's why we have to use the Q. That means the value of rational numbers will be obtained in the quotient place. That's why we have to represent the rational numbers by Q. Okay. Now examples. These are the examples of rational numbers that are 1 by 4, 3 by 2, 11 by 79 and minus 2001 by minus 2001 by 2002. These are the examples of rational numbers. And here you need to understand that these three numbers are fractions as well as rational numbers. But this is only as a rational number which is not a fraction. Why? Because in fraction negative numbers are not allowed. Here negative number is there, so it is treated as only rational number. But these three rational numbers are treated as rational numbers as well as fractions. That you need to notice. Okay, let us see the next slide, which is of some of the important concepts, important properties of this. That are, there are infinitely many rational numbers. There are infinitely many rational numbers, and there is no least or greatest rational number. There is no least rational number or greatest rational number. And third point is that 0 is a rational number. Why? Because 0 can be written as 0 by 1, which is in the form of p by q. So 0 is a rational number. And you need to understand the fourth point, that is of every rational number is a rational number. Every rational number is a rational number. Every natural number is a rational number. Every natural number is a rational number, because every natural number can be written in the form of p by q by taking denominator 1. Okay. Next, the same manner, every integer is a rational number. Since every integer can be written in, as a form of a by 1. If you take an integer as a, then a can be written in the form of a by 1. Okay. Likewise, that is which is in the form of p by q. That's why we say that every integer is a rational number. Okay. Now if you observe this last point, the rational numbers includes the natural numbers, whole numbers, and integers. The rational number includes the natural numbers, whole numbers, and integers. If you draw the diagram for this, firstly we learnt about a natural number, and we extended it by the whole numbers by adding 0 to it. Then set of whole numbers, it is extended to the integers by taking the negatives of natural number. Then we extended this set of integers by taking rational numbers. Okay, that means set of integers, set of rational numbers includes a set of natural numbers and set of whole numbers and set of integers. Okay, now let us see the next slide, that is of simplest form of a rational number. Simplest form of the rational number. A rational number p by q. A rational number p by q is said to be in its simplest form if p and q are integers having no common factors other than 1. That means if a rational number is given to us, then it is said to be in a p by q form. It is said to be in simplest form when p and q are not having any common factors. That means if two numbers are not having any common factors, then the two numbers are said to be as a co-prime. Let us see that what is the difference between the normal form and simplest form. Okay, the simplest form of 2 by 4. What is the simplest form of 2 by 4? Here, if you understand this, 2 is this fraction. Let us suppose this is a rational number. In this rational number, 2 is a numerator and 4 is a denominator. And what are the factors of 2? That are 1 and 2. Factors of 4, 1, 2, 4. That means these two numerators and denominator. That means this numerator and denominator are having 2 as a factor other than the 1. So then we cannot say that 2 by 4 is not in simplest form. Then in order to make it into simplest form, what we need to do? We need to divide the given rational number by the common factor other than 1. What is the common factor other than 1? That is of 2. On dividing this, you will get a 2 divided by 2 means quotient is 1, and 4 divided by 2 means quotient is 2. That is then 1 by 2 is said to be the simplest form of 2 by 4. In the same manner, 3 by 6, the simplest form of 3 by 6 is also 1 by 2, and simplest form of 4 by 6 is 1 by 2. Simplest form of 5 by 10 is 1 by 2. And here if you understand, the simplest form of 6 by 9 is 2 by 3. Why? Because 6 and 9 are having a common factor other than 1 as a 3. Okay, they are having a 3 as a common factor other than 1. That's why To write this into simplest form, we need to divide 6 by 9 by a common factor other than 1, that is of 3. So numerator and denominator both will be divided, should be divided by common factor other than 1. So you will get 2 by 3. In the same manner, the simplest form of 95 by 113, 95 by 113 is 5 by 7, 5 by 7, because both will be divisible by 19. Okay, so let us see the next topic, that is of representation of rational numbers on the real line. Okay, representation of rational numbers on the number line, real line or number line. So to represent the rational numbers on the number line, we need to draw a line xy which extends endlessly on the both directions. We need to draw a line xy which extends endlessly on the both directions and take a point O on it. Take a point O on it and let it as a 0. Then we need to represent it as a, we need to suppose it as a 0. Then take a fixed length which is called as unit length, mark of OA. If you take from A, from O, if you take a fixed length OA as a 1 unit, then you need to take it as an OA, and this is of 1 unit. Okay. Likewise, in the same manner, take a midpoint of OA, midpoint of OA as a B. Then this B represents a half of this 1 unit, half of this 1 unit. That's why it is represented by 1 by 2. Okay, that means what? In this slide, I am going to show that how to represent a rational number with a denominator 2. So, if you observe this number line, you can understand that. Okay, I firstly have drawn a line xy which extends endlessly on both directions. This arrow heads represents that this line extends endlessly on both directions. Then I took a point O and I consider it as 0, and I took a fixed length OA as a 1 unit. Then this midpoint of this I took as a B. This B represents half of that unit. That's why 1 by 2 is a number line, and 2 by 2 is what? 1 itself. 3 by 2 again from OA I took another point, equal distance of OA, 2 times of OA I took. Then I got this point, and in this half 3 by 2. Likewise, okay, let us see this. From point O on right side, on the right, then points at the distance of OB, 2 times of OB, 3 times of OB, 3 times of OB is 3 by 2. Okay, 1 time of OB is 1 by 2, 2 times of OB, 2 by 2, 3 times of OB, 3 by 2, 4 times of OB, 4 by 2. Likewise, towards the right we have to take like this, and the same manner towards the left. Similarly, from the point O on the left, the points of the equal distance of OB as a OB, see, equal distance. 1 OB is what? Minus 1 by 2, and 2 times of OB is minus 2 by 2, 3 times of OB is minus 3 by 2, and 4 times of OB is minus 4 by 2. Likewise, we need to represent we can represent any rational number on the number line very easily like this. And if you understand this concept, let us see that how to represent that rational number with a denominator 3. Rational number with a denominator 3. This is a number line which shows that representation of a rational number with a denominator 3. Okay, so firstly I took a distance. I firstly have drawn a line xy which extends endlessly on both directions. I took a point O and I consider it as 0, and I took a unit length OA, and in this OA have divided into 3 equal parts. In that, first part represents 1 by 3, and second part represents 2 by 3, third part represents 3 by 3 which is of 1, and fourth part represents 4 by 3 which is okay. Likewise, towards the left also you will get a fixed unit Then I divided that into 3 equal parts. In that first part is minus 1 by 3. Second part is minus 2 by 3. Third part is minus 3 by 3, which is of minus 1. Okay, this is how to show that or else represent the rational numbers on the number line. Okay, now let us see an example. Represents a 2 whole 3 by 8 and minus 1 by 5 by 7 on the real line. Represents the 2 whole 3 by 8 and minus 1 whole 5 by 7 on number line. Let us see the next example. Here 2 whole 3 by 8. 2 whole 3 by 8 means what? This number 2 whole 3 by 8 which lies between 2 and 3. Which lies between 2 and 3. So firstly we need to draw a number line and take a point O as a 0 and a unit length we have to take. Then OA and 2 times of OA you get OB which is of 2 units and 3 times of OB OA is OC. Then you will get a point C then which is of 3 units. Then we need to represent my 2 whole 3 by 8. That means which lies between 2 and 3. That means which lies between B and C. So the place in which between the point B and point C should be divided into 8 equal parts. Why are we representing? Why we need to divide into 8 equal parts? Means here denominator of this fraction is 8. So we need to divide into 8 equal parts. And dividing into 8 equal parts, this first part is represented as 2 whole 1 by 8. Second point represented as a 2 whole 2 by 8. And third point P which represents a 2 whole 3 by 8. 2 whole 3 by 8. Likewise, you can represent a minus 1 by 5 by 7 also on the other hand of this. Okay. So, if you take minus 1 by 5 by 7, if you take minus 1 by 5 by 7 on the left of this O, on the left of 0, take a fixed distance OA, then you will get a point D. Then this I consider as a minus 1 and 2 times of OA if I take, you get a point E which is we consider as a minus 2. Then the place between a D and E should be divided into 7 equal parts in this case. Why? Because second rational number consists of 7 in the denominator. So 7 equal parts, I am dividing it into 7 equal parts. Then in that fifth part we consider as a 7 equal parts. 1, 2, 3, 4, 5, 6. In this fifth part is Q which represents minus 1 by this Q represents a minus 1 whole 5 by 7. This P represents 2 whole 3 by 8. 2 whole 3 by 8. Okay. So depends upon the denominator we need to divide. Okay. Now let us see the next concept. That is finding the rational number between the two given rational numbers. Finding a rational number between two given rational numbers. Here, for this you need to know an important property which is called the density property of rational number. If you take any two rational numbers, A and B, then how many rational numbers which lies between these two? Means there are infinitely many rational numbers will be. In that one rational number is A plus B by 2. In the same manner, if you take X and Y are two rational numbers, then a rational number which lies between these two is half of X plus Y. Okay, half of X plus Y. So by using this concept, we can find out a rational number between the two given rational numbers. Okay, let us see that concept. So in this first method is that suppose we are required to find the one rational number between the two rational numbers X and Y such that X is less than Y, the Y, then we need to use this formula, that is half of X plus Y is a rational number which lies between the X and Y. Okay, average of X and Y should lie between X and Y. So example, find a rational number which lying between 1 by 3 and 1 by 2. And second question is 2 by 3 and minus 3 by 4. So if I suppose first number as a x, that is x is equal to 1 by 3, and second number I suppose as a y, then y is equal to 1 by 2. Then rational number which lies between x and y is half of x plus 5, that is half of 1 by 3 plus 1 by 2. The sum of 1 by 3 and 1 by 2 is 1 by 6, 5 by 6. Then half of 5 by 6, that is half 5 by 12. Then 5 by 12 is a rational number which lies between 1 by 3 and 1 by 2. 5 by 12 is a rational number which lies between these two. And second question, you can try for the second answer. Okay. Now let us see the second method. In the second method, suppose when we need to use this second method also, you need to understand. Suppose we are required to find out n number of rational numbers lying between the two rational numbers x and y with a like denominator. Then convert the given rational numbers into equivalent rational numbers by multiplying the numerator and denominator by suitable number. Usually we take as an n plus 1. Now required rational numbers may be manually chosen. I hope you did not understand anything in this method if you read so what we need to do, if I take 4 by 6 and 9 by 6 is there. Okay, so these two are rational numbers, and they ask us to write three rational numbers which lies between these two. Means we can consider these as a max out of 6, or else you can consider just as a numbers. If you suppose 4 by 6, 9 by 6. Okay, and if you consider that these two rational numbers are having same denominator, that means these two rational numbers are having same denominator, means like rational numbers. So if these two are like rational numbers, you need to observe the numerators. Do we have any gap between numerators? So 4 and 9, yes, we have a gap between 4 and 9. In this gap, what numbers will be, what natural numbers which lies between 4 and 9? That are 5, 6, 7, 8. So apply denominator 6 for these all natural numbers. So you get a rational numbers which lies between 4 by 6 and 9 by 6. Okay, these are the rational numbers which lies between 4 by 6 and 9 by 6. But if you don't have the rational numbers which are having same denominator, then what we need to do means we need to make them into same denominator by taking the LCM. So let us see an example for this. Okay, find the 5 rational numbers between 3 by 5 and 4 by 5. Here 3 by 5 and 4 by 5. 3 by 5 and 4 by 5. These two are like fractions because they are having same denominator. And if you observe the numerator, there is no gap between 3 and 4. There is no natural number which lies between 3 and 4. In that case, what we need to do means you need to observe the question. We need to observe the question that we need to insert 5 rational numbers. So we need to suppose n is equal to 5. If you want to insert 5 rational number, then each rational number should be multiplied by 5 plus 1. That means 6. That means numerator and denominator of each rational number should be multiplied by 6 by 6. That means if you take first rational number 3 by 5, this should be multiplied by 6 by 6. Then you get the first rational number as 18 by 30. And second rational number we have 4 by 5. And in this also we need to multiply the numerator and denominator by 6 by 6. So you get 24 by 30. Again, these two rational numbers are equivalent rational numbers to the given rational numbers, and which are having same denominator. But in this case, if you observe the numerators 18 and 24, do we have any natural numbers which lies between 18 and 24? Yes, we have. So what are that? 19, 20, 21, 22, 23. So apply the denominator 30 for these all natural numbers. So that you get 5 rational numbers which lies between two given rational numbers, that are 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. These are the 5 rational numbers which lies between 3 by 5 and 4 by 5. This is another method which you have to follow to insert the rational numbers. Okay, first method is what? Mean method. That means average we need to find out. Okay, in this case, we need to make them into like denominators and we need to multiply the suitable number. Okay, so let us see the next concept, that is of decimal representation of rational numbers. Decimal representation of the rational numbers. That means if you want to convert any rational number into decimal form, what we need to do means we need to divide the numerator by denominator. Suppose we have given with a rational number p by q. If you want to convert this into decimal form, then we need to divide the numerator by denominator. So by that, what type of decimals that you are going to get? Let us observe that. That are, first one, if you take first rational number is 1 by 4, then on converting into decimal form, you get 1 by 4 as 0.5, like this. That means on dividing 1 by 4, you will get 0.5 as a quotient. This quotient is the decimal form representation of a rational number 1 by 4. In the same manner, if you observe second rational number 5 by 8 and on dividing 5 by 8, you get a quotient as a 0.625. You get a quotient as 0.625. So that you got this as a decimal form of 5 by 8 is 0.625. And let us see the third one. Third one is what? 2 by 3. On converting this into decimal form, you get 0.666. And how many times you get the 6? Infinitely many. That means this division will continue endlessly. In that case, we represent that as a 0.6 bar. And if you observe the fourth example, that is of 11 by 6, on converting into decimal form, you get this value as a 1.83 bar for 3. And here, if you understand, in the first two decimal representation, this division comes to an end. That means division process is completed in the first two cases. In the second two cases, division process is not completed. It is continuous. How long will it continue? It continues endlessly. So by this, you need to understand that there are two cases arises on dividing the numerator by denominator. You will be having two cases. What are that? Let us discuss. See, every rational number which is in the form of p by q can be expressed as a decimal on dividing p by q. There are two possibilities arises. That is of first one, a remainder comes to the 0, becomes a 0. That means the division completes after the finite number of steps. In this case, decimal expansions obtained also is terminates or end. That means in first case, if you understand these two cases, first two examples are the suitable for the first case. Okay, so division process completes in this case. In the next case, division process is not completed. If not completed, what will be happen? The remainder never becomes a 0 and a repeating string of remainders is obtained. Repeating string of the remainders are obtained. Then we get a digit or a block of digits repeating in the decimal expansion. That's we have two types of decimal expansions. Two types of decimal expressions that are terminating decimals. In that first one is what? Terminating decimal. Terminating decimal means what? A decimal that ends after a finite number of digits is called as terminating decimal. A decimal that ends after finite number of digits is called as terminating decimal. Example 1 by 4, which on dividing it you get the remainder is 0. That means division process completed and we have finite number of decimal places in it. Then it is said for terminating decimal. And here also second example 5 by 8 is having finite number of decimal places in it that are 6 to 5. That means there are 3 number of decimal places in this. In the first example we have 2 number of decimal places. Okay. And second type of decimal numbers is a non-terminating repeating decimal. Before going to discuss that non-terminating repeating decimal, let us see how to identify the given rational number, whether it is a terminating or non-terminating, without doing actual division. Means if a rational number p by q is expressed as a terminating decimal only when the prime factors of q are 2 and 5. Only when the prime factors of denominator q are 2 and 5. Okay, 2 and 5 only. That means other than 2 and 5, they should not having any other common factors. If you observe this 1 by 2, denominator is 2, prime factor of is 2 only. So it is a terminating decimal. 3 by 4 is the prime factor of 4 is 2 into 2. So it is a terminating decimal. If you take 20, 20 can be written as what? What is the prime factorization of 20? 2 tens 2 5s. That means this contains a 2 and 5 only. Then it is said without terminating decimal. And 13 by 25. 25 is represented as a 5 into 5. So these rational numbers can be expressed in the form of terminating decimal. Why? Because these denominators are having only 2 factors that are 2 and 5. Okay, let us see the next one, that is of repeating or non-terminating repeating or recurring decimal. A decimal in which a digit or set of digits is repeated periodically is called as a repeating decimal or recurring decimal. Example. Okay, let us see an example. 2 by 3 is this on dividing 2 by 3, this division process will not come to an end. Then you get the 0.666 and so on. And in this, a group of digits, that means a digit is being repeating. That digit, instead of writing repeated time, just we need to write down, we place a bar over the first digit. Then we omit the rest all. So that's why we can write it as a 0.6 bar. 0.6 bar. And if you observe next important case is that in the non-terminating decimal numbers, how to represent a non-terminating decimal number in the form of p by q. How to represent the non-terminating repeating decimals in the form of p by q. So if you take an example, express 1.4 bar as a fraction in simplest form. Express 1.4 bar as a fraction in simplest form. So for that, I am supposing that x is equal to 1.4 bar. As it is 1.4 bar, this bar without bar, we can write it as an x can be written as x is equal to 1.444 and this 4 continuously. And if you observe that since the repeating black has only one digit, in this how many digits are being repeating? One digit only. What is that? 4. So repeating black is having only one digit, that is of 4. Then x should be multiplied by 10 on both sides. X should be multiplied by 10 on both sides. On multiplying by 10, x we have as a x is equal to 1.444, and on multiplying it by 10 on the both sides, you get a 10x is equal to 10 into 1.44. That means you get a 14.44 and so on. Okay. Now this you can suppose as a second equation. Now we need to subtract first equation and second equation. What is the first equation? That is x is equal to 1.444. And subtracting this, you get a 10x minus x, 9x. 9x is equal to 14 minus 1, that is 13.4. 4 minus 4, then you get all the decimal places becomes 0. From this you get 9x is equal to 13. Then x can be written as 13 by 9, which can be written as 1 whole 4 by 9. 1 whole 4 by 9. This is how to write a non-terminating repeating decimal in the form of P by Q. Here, as we have only one digit is repeating, we need to multiply it by 10. If there are two numbers are repeating, then we need to multiply it by 10. 100, sorry. Let us see that example. Express 0.57. Express 0.57 in the form of P by Q, where P and Q are integers and Q is not equal to 0. If you observe that, if I suppose x is equal to 0.57, 57 in the bar means 57 will be repeated. That means in this case, how many digits are repeating? 2 digits are repeating. If 2 digits are repeating, by what number should we multiply? You should multiply it by 100. So that what you will get, 100x is equal to 57.5757 and so on. And this I am supposing is the first equation, second equation. And on subtracting this second equation, first equation from second equation, here we have second equation as 100x is equal to 57.5757 so on, and x we have first equation we have as an 0.5757 so on. On subtracting it, you get a 99x is equal to 57. From this, x is equal to 57 by 99. Both will be divisible by 3 table. So on simplifying it, you get x value as a 19 by 33. So that we can write 0.57 bar can be written in the form of fraction as a 19 by 33. 19 by 33. Okay. These are the important concepts which are necessary to learn about rational numbers. Thank you students for watching this video.